Hello, and welcome to Lesson 10.6a, Factoring Quadratic Trinomials, when a is equal to 1. Our objective for today is that I can determine the factors of trinomials with a leading coefficient of 1. So what is this leading coefficient, this a equals 1 stuff relating to? It's relating to the standard form of a quadratic trinomial. Quadratic meaning you have an x squared term. Trinomial, there's 3 terms in our expression. So our standard form is ax squared plus bx plus c, where a, b, and c are each going to be coefficients or a constant that we're going to be working with. So in the case of everything we're doing today, our a value, this first term, is just going to be a 1. So it's just going to be x squared plus bx plus c. So a prime polynomial is a polynomial that cannot be written as the product of 2 polynomials with integer coefficients. All right, so let's look at example 1. We're going to have c values that are positive and b values are also going to be positive. So when we factor, we are undoing the multiplication and distribution that we do with FOIL. We're breaking something apart into its 2 pieces that multiply together. So what we're going to do here, we're going to look for the factors of 24 that have a sum of 11. And we'll walk through kind of the why at the end of this. So first off, my factors of 24. I have 1 and 24, and that gives me a sum of 25. So that's not it. We have a 2 and a 12. That gives me a sum of 14. We're getting closer, still not it. 3 times 8, that gives me a sum of 11. So my binomials are x plus 3, x plus 8. All right, now with factoring, part of the beauty is that you can always check your work. So let's check our work. X times x, x squared. X times 8 plus 8x. 3 times x plus 3x. 3 times 8 plus 24. All right, so this is where our 2 components are coming from, because you can see our product, right? Our second term in the binomial, the first term, sorry, let's rewind. The first terms, right, we know are just going to be x and x because they give us just x squared. So they can only be an x. Now, our second term in the binomials, the 3 and the 8, those 2 are going to multiply at the end there with the last action to give us that 24, which we see right there. Now, the sum are 2 factors, right? It's x times 8 and 3 times x, the outer and the inner in FOIL. Those give us these 2 factors right here that when you combine like terms, you add them together and you get 11x. All right, so, and when we do that, that is what we have here, x squared plus 11x plus 24. Right, so we are undoing the actions of FOIL when we factor. We are breaking it apart into our components. All right, let's look at letter B. We have x squared plus 6x plus 8. So we're looking for factors of 8 that are going to add up to 6. So my factors of 8, we've got 1 and 8. The sum of those is 9. We have 2 and 4. The sum of those is 6. So we have x plus 2, x plus 4. All right, x plus 2, x plus 4. Now, 2 U-try problems. Go ahead and try those on your own, and then check your work against mine. All right, x squared plus 9x plus 20. We're looking for factors of 20 that add up to 9. So my factors of 20. So we've got 1 and 20, and that gives me a sum of 21. We've got 2 and 10, that gives me a sum of 12. 4 and 5 gives me a sum of 9. So we have x plus 4, x plus 5. Okay. Letter D. we have x squared plus 7x plus 12. So we're looking for factors of 12 that add up to 7. So we have 1 and 12. That'll be a sum of 13. We have 2 and 6. That gives me a sum of 8. And we have 3 and 4, which gives me the sum of 7. X plus 3, x plus 4. All right. Now, what if we have a C value that's positive, so our product is positive, but our B value is negative? Well, B is the bossy value. It's the one that's in control of what the signs are going to be. So if B is negative, that means our factors are negative, or at least one of them is. And since C is positive, that means both of our factors are going to be negative, right? Because a negative times a negative gives us a positive value, but two negative numbers added together are going to stay negative. So our factors of 16, you could have negative 1 and negative 16, whose sum is negative 17. We've got negative 2, negative 8, which gives us a sum of negative 10. So you have x minus 2, x minus 8. Okay? And again, we can double check our work on this. X times x is x squared, minus 8x, minus 2x, plus 16. Right? And then you combine like terms, x squared minus 10x plus 16. Okay? All right. And again, you can see where all these pieces are coming from. All right, letter F. So we've got factors of 27 that are going to add up to negative 12. Factors of 27 that add up to negative 12. Well, we've got negative 1 and negative 27, which is negative 28. We have negative 3 and negative 9, which is going to give me negative 12. So we have x minus 3, x minus 9. All right. Now, if you flip over to the backside, you'll have two U-try problems at the top of the page. Do those on your own and then check your work against mine. All right, letter G, we have x squared minus 6x plus 8. So we're looking for factors of positive 8 that add up to negative 6. So we have negative 1 and negative 8. That adds up to negative 9. And we have negative 2 and negative 4, which adds up to negative 6. So we have x minus 2, x minus 4. All right, letter G, we're looking for factors of 30 that are going to add up to negative 11. So factors of 30, we have negative 1, negative 30. That gives me a sum of negative 31. We have a negative 2 and a negative 15. That gives me negative 17 as the sum. Negative 3 and negative 10. That gives me negative 13. And then we go to negative 5 and negative 6, which gives me negative 11. So we have x minus 5, x minus 6. All right, let's go to example 2. And now we have C values that are negative and a B value that's positive. So again, we're coming back to that bossy B value again. The B value is telling us what's going on. So we are looking for factors of negative 36 that are going to add up to a positive 9. So that means if we're going to multiply together to be a negative, one's positive, one's negative. But if they're going to add together to be positive, that means the positive value has to have a greater magnitude or be, quote unquote, bigger than the negative number. All right, so when we look at it, let's kind of work our way through. We're looking for factors of negative 36. So negative 1 and positive 36, that gives me a sum of 35. negative 2 and 18. That gives me a sum of 16. Negative 3 and 12 gives me a sum of 9. So we have x minus 3, x plus 12. And then let's just double check our work on this one. X times x is x squared plus 12x minus 3x. 12 minus 3 is 9. And then minus 36. So x squared plus 9x minus 36. So we can see that we're correct. Beauty of factoring. You can check your work every single time. All right, let's look at letter B here. We're looking for factors of, and I left it blank, I'm going to have you fill it in, factors of negative 16 that have a sum of 6. So we've got negative 1 and 16, that's a negative, not a negative, that's a 15 for the sum. And we've got negative 2 and 8, that gives me a sum of 6. So we have x minus 2, x plus 8. All right, x minus 2, x plus 8. All right, there's 2 U-try problems. I'd like you to do those on your own now and check your work against mine. All right, letter C. We're looking for factors of negative 27 that add up to positive 6. So we've got negative 1 and 27. That gives me a sum of 26. We've got negative 3 and positive 9. That gives me a sum of 6. So we have x minus 3, x plus 9. All right, x minus 3, x plus 9. And letter D, x squared plus 5x minus 14. So we're looking for factors of negative 14 that are going to add up to 5. Okay, so we have negative 1 and 14. That gives me a sum of 13. Negative 2 and 7 gives me the sum of 5. X minus 2, x plus 7. All right, that's the end of that one. So now we're going to go to example 3, which is our C value is negative and our B value is negative. So in this case, the bossy B value is telling us that my negative term has to be the larger of the two, because when we add them together, it's still going to be negative. So factors of negative 18 that add up to negative 7, well, we've got negative 18 and 1, which is negative 17. We've got negative 9 and 2, which is negative 7. Sorry, negative 9 and positive 2, which is negative 7. So we have x minus 9, x plus 2. And we can check our work, as always. X squared plus 2x minus 9x minus 18. And then when you combine like terms, x squared minus 7x minus 18, just like what we have up above. All right, letter B, x squared minus x minus 20. So we're looking for factors of negative 20 that add up to negative 1. So we have 1 and negative 20, which is negative 19. We have 2 and negative 10, which is negative 8. And you have 4 and negative 5, which gives us negative 1. So x plus 4, x minus 5. All right. Okay, so now on the top of the next page is our next set of U-try problems. So go ahead and give them a shot. Check your work against mine when you're done. All right, letter C. We've got x squared minus 4x minus 21. So we're looking for factors of negative 21 that have a sum of negative 4. So we've got negative 21 times 1, which gives us negative 20. We've got negative 7 times 3, which gives us negative 4. So we have x minus 7 and x plus 3. Now, we actually didn't talk about this earlier, but as you look at this, does it have to be written in that order? Could it be written as x plus 3 times x minus 7? Absolutely, right? These two are interchangeable. You can have them in different places, right? That properties of multiplication that we did all the way at the beginning of the year tell us that you can multiply in any order. So whether it's x plus 3 is first or second binomial doesn't actually matter in the outcome. All right, letter D. So we're looking for factors of negative 40 that are going to add up to, not negative 40, that's a different problem. We're looking for factors of negative 35 that add up to negative 2. So my factors of negative 35, so we have negative 35 and 1, which is negative 34, and we've got negative 7 and 5, which gives us negative 2. So we have x minus 7, x plus 5. All right. Let's look at example 4, where we're going to factor each polynomial, and if the polynomial cannot be factored using integers, we're going to write prime. So we're looking at x squared minus 4x plus 8. So we're looking for factors of 8 that add up to negative 4. Well, negative 8 and 1 gives me negative 7. Negative 4 and 2 gives me negative 2. Still not there. Negative 2 and 4, that's going to give me 2. And negative 1 and 8 gives me 7. Well, none of those are negative 4, so this one is prime. There are no integer factors that we could find on that one. All right, letter B. We've got x squared plus 7x plus 6. So we're looking for factors of 6 that add up to 7. So we've got 1 and 6 adds up to 7. Super easy. X plus 1, x plus 6. All right. Go ahead and do letters C and D on your own and check your work against mine. All right, letter C. We have x squared minus 8x plus 12. So we're looking for factors of 12 that have a sum of negative 8. So our larger factor has to be the negative one. So negative 12 and positive 1, that's negative 11 for the sum. Negative 6 and, sorry, they're both negatives because it's negative times negative gives me a positive. So that's negative 13, not negative 11. So negative 6 times negative 2 gives me positive 12 and adds up to give me negative 8. So we have x minus 6, x minus 2. All right, with letter D, x squared plus 3x minus 40. We're looking for factors of negative 40 that add up to 3. So we have positive value is going to be our higher one. So we have 40 and negative 1, right, to get our negative, and that's going to be a sum of 39. We have 20 and negative 2, that gives us a sum of 18. We've got 10 and negative 4, that gives us a sum of 6. And then we've got 8 and negative 5 gives us a sum of 3. And so it's x plus 8, x minus 5. Now, as you're working, are you going to be able to start to shortcut these and be able to not need all of the factors listed out? Absolutely. But it'll take some time to get there. All right. Now, factor a polynomial with these kind of word problems. So Switzerland's flag has a very unique shape in that it is a square. However, the flag used by the country's naval vessels is rectangular. If the area of the square flag is x squared minus 6x plus 9 square feet, and the length is increased by 4 feet, then what is the area of the naval flag in terms of x? All right, so this is actually going to be a two-part problem. First part, we need to figure out what are the two side lengths of the square flag. So we're going to factor x squared minus 6x plus 9. So if I factor that, I'm looking for factors of 9 that add up to negative 6. Well, I know my first factor is negative 1 and negative 9. That adds up to negative 10. But negative 3 and negative 3 multiply together to be positive 9 and add to be negative 6. So x minus 3. Hey, look, that's one of those special cases that we looked at. That's a perfect square trinomial. Interesting. We might be revisiting those special cases a little bit later. Anyway, so here we have our side lengths are x minus 3. So if we have an area, the length is increased by 4 feet. So if we say this is the length and this is the width, my length, one of these is going to increase by 4 feet. So instead of x minus 3, it'll be x plus 1. And then the width is staying the same, x minus 3. All right, so now we FOIL x squared minus 3x plus x minus 3. And when we combine like terms, we get x squared minus 2x minus 3. All right, and that's our area in terms of x for the naval flag, which had one side get increased more than the other, or compared to another. All right, let's look at letter B. Mindy is a landscaping contractor who has devised a formula for the area of a new patio given the changes in the length and width. The customer's patio is x squared plus 10x plus 25 square feet, and the customer wants to increase both the length and the width by 6 feet. Write an expression for the new area. All right, so we are going to take our original and figure out what our two sides are. X squared plus 10x plus 25. Interesting. That does seem like my first term is squared, my last term is squared, my middle is the first one times the last one times 2, but 10x. I'm looking for factors of 25 that add up to 10. 5 times 5 is 25. 5 plus 5 is 10. So we have x plus 5, x plus 5. All right, so now if we want to increase length and width by 6 feet, it's now x plus 11 times x plus 11. And when we do that, we get x squared plus 11x plus 11x plus 121, which we simplify by combining like terms to be x squared plus 22x plus 121. Okay, so for these, you're going to actually be doing 2 steps. You're going to be factoring it, and then you are going to be foiling it with your new values. Okay, that is the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.